Fatality of the chief engineer on board the motor yacht Baton Rouge at Falmouth Harbor, Antigua on the 23rd of February 2024. Background: this investigation into a very serious marine casualty was conducted by the Marine Accident Investigation Branch on behalf of the Isle of Man Ship Registry A, member of the Red Ensign Group. Summary: on the morning of the 23rd of February 2024, the chief engineer on the Isle of Man registered motor yacht Baton Rouge was electrocuted while working on the vessel's engine room ventilation system. The chief engineer was replacing a damper actuator, which was situated in a ventilation overpressure duct compartment. Despite efforts to resuscitate him, the chief engineer's heart could not be restarted, and he was pronounced dead later that morning. The investigation found that the chief engineer commenced the actuator replacement without isolating the electric supply and without a permit to work for electrical maintenance in place. This was likely because he had rationalized the risk and wanted to avoid the limitations of restricting the vessel to emergency power. It was also found that the location of the overpressure duct compartment and the means of access to it met the definition of an enclosed space in industry guidance. However, the definition in the onboard safety management system was not aligned to this and instead focused on toxic atmospheres. As a result, the crew did not consider the overpressure duct compartment to be an enclosed space and did not follow enclosed space working and entry procedures. Since the accident, the yacht's manager, Nigel Burgess Limited, has updated its permit to work guidance for electrical systems, revised the enclosed space definition in the safety management systems of vessels under its management, and promulgated fleet guidance on the changes to the enclosed space definition, permits to work, and the need for onboard risk controls, training and drills. In view of the actions taken, no recommendations have been made in this report. Baton Rouge image courtesy of Nigel Burgess Limited. At around 9 p.m. on the 22nd of February 2024, Baton Rouge lost electrical power. When the power had been restored, an engine room ventilation damper located in the starboard ventilation overpressure, the UCT compartment shown in Figure 1, failed to reset and remain closed. The compartment containing the starboard ventilation overpressure duct was accessed via a bolted hatch cover in a storage locker on the bridge deck. At approximately 10 p.m., the chief engineer, assisted by the second engineer, removed the bolted hatch cover and the CD entered the overpressure duct compartment to inspect the failed ventilation damper. No permit to work was issued for this task. The chief engineer removed the failed actuating mechanism and opened the damper, leaving the actuating mechanism connected to the 230-volt alternating current volts AC electrical power supply. The chief engineer then exited the overpressure duct compartment, leaving the hatch cover off to allow for airflow through the duct. The chief engineer and master discussed the repair and decided the work would be continued the following day. At 07:00 on the 23rd of February 2024, the day of the incident, the chief engineer and the master discussed the repair task. The ambient temperature inside the overpressure duct compartment was 50 degrees Celsius to 55 degrees Celsius, so, to reduce the risk of heat exhaustion, the master and chief engineer agreed that the chief engineer would limit his time inside to 10 minutes followed by a period for rehydration. This was to be monitored by the chief officer from the bridge deck. The chief engineer agreed to inform the chief officer via ultra-high-frequency UHF radio each time he wished to enter the overpressure duct compartment. The master understood that the task could be completed with the vessel's main generators running. No PTW was issued for entering the overpressure duct compartment or for disconnecting and replacing the electrical wiring for the actuator. Before starting work, the chief engineer assigned several engine room-based tasks to the second engineer. These tasks did not include helping with the repair work, which the chief engineer had elected to complete without assistance. At 7:23 a.m., the chief engineer went to the engine room to gather tools and replacement parts. At 7:30 a.m., the chief engineer entered the overpressure duct compartment for the first time that day, having first informed the chief officer via the UHF radio. Between 7:34 and 8:48 a.m., the chief engineer made 3 return trips from the overpressure duct compartment to the engine room for additional equipment. He informed the chief officer via the UHF radio each time and took rehydration breaks. For the first 3 entries, the chief officer remained on the bridge deck while the chief engineer was in the space, periodically checking on him. In between entries, the chief officer worked in their office. At some point after 848, the chief engineer entered the overpressure duct compartment for a final time and continued the work with the actuator wiring on the open electrical junction box. Post-accident analysis of the closed-circuit television CCTV showed that he was visibly hot and sweaty as he approached the bridge deck. At 0856, a series of engine room ventilation system alarms were activated on the machinery monitoring system. The second engineer, who was completing tasks in the engine room, observed the alarms and ran to the overpressure duct compartment entrance to inform the chief engineer. When the second engineer arrived at the entrance, they saw the chief engineer slumped over the ventilation trunking in the space. The second engineer shouted to the chief engineer but received no response, so ran to the crew mess to raise the alarm. At 8:58 a.m., the alarm was raised via the UHF radio, and the chief officer immediately ran from their office to the overpressure duct compartment and climbed down the ladder to reach the chief engineer. The chief officer received an electric shock from the chief engineer when they touched him. The rescue. On deck, the crew responded to the emergency call and began preparations to rescue the chief engineer. In the overpressure duct compartment, the chief officer assessed that the chief engineer had suffered a cardiac arrest and attempted to carry out cardiopulmonary resuscitation (CPR). The master alerted the Marina Harbor authorities to the situation via the bridge UHF radio. At 0902, Antigua and Barbuda search and rescue officer was called. After several unsuccessful attempts to extract the chief engineer from the overpressure duct compartment, the crew of Baton Rouge eventually succeeded in removing him by using an endless sling around his chest and supporting his legs while hauling him from above. The chief engineer was laid on the bridge deck, where the crew continued CPR. At 0910, ABSAR paramedics arrived on Baton Rouge and took over the chief engineer's care. At 9:52 a.m., an ambulance arrived and transferred the chief engineer to a local hospital accompanied by the chief officer. The chief engineer was declared deceased at 10:19 a.m.
Conclusions. The chief engineer was electrocuted because he came into contact with live to 3 VAC conductors while working on the ventilation damper electric circuit. The reason why the chief engineer came into contact with the live conductors is unknown. The PTW system was not used to identify the hazards associated with the repair task and put measures in place to mitigate them, meaning that the risk of injury to the chief engineer was not fully addressed before the work began. This was likely because the crew did not recognize the work area as an enclosed space and there was a lack of challenge from authorizing officers. The chief engineer had probably chosen to work on the live circuit to avoid the limitations of restricting the vessel to emergency power. In doing so, it is possible that he rationalized that the level of risk from the non-isolated circuit was small. The chief engineer was a lone worker in the space. The monitoring arrangements in place did not amount to a dedicated sentry. No one observed the chief engineer's final entry to the space, and immediate action could not be taken when he came into contact with the live conductors. No rescue plan had been put in place to recover a person from the overpressure duct compartment.